So, hello everybody. It's about time to start. I'm Luigi. I'm gonna present you a first introduction about this meeting and why we are here and who is here and what we want to discuss with you in general. Okay, so not well. This is still under the IETF blanket, so not well applies. You have read this during the registration process in principle. Basically, it says that whatever we say here in this side meeting still is IETF contribution. Okay, and just to let you know, this is also streamed on YouTube, and so which means that there will be a recording afterwards. We plan to make it public on the GitHub repository that we have. What you see here is a little bit the logistics. So we have 60 minutes for us. If you are listening to me, you know the WebEx link, or you find out the live stream on YouTube. There is also the link for the materials, and I hope please pay attention to mute yourself when you don't speak, so to avoid disturbing noises. Okay, you can raise hand, ask to make question or discuss. Mainly Dirk Trosten that will lead the discussion later on. We will call you and so that you can have the mic and ask or discuss, make your point. Feel free to chat, okay, in the chat window. This is welcome. For question and discussion beyond this meeting, I will point you to the Intaria mailing list, which leads me actually to the next slide, which is basically why we are here. So I will make the technical points in a couple of minutes, but the reason why we are here from a non-technical standpoint is that I guess you know that there is a pandemic going on on Earth, so which means that this is also impact a little bit on the work we do in the IETF. In particular, bringing new work to the IETF is harder. It's already hard to go on with the usual work, but bring new work, it's harder because of the way the IETF works. So this is also being pointed out actually in the previous IETF in 111 with a few statistics that have been shown. Okay. So especially for 0.0 draft and new discussion is becoming very hard. So we thought that maybe we can set up a side meeting in order to trigger the discussion and have more interaction. That way can be considered as an experiment, because this meeting is not about setting the stage for a BOF. It's really about promoting broader thinking, specifically on two drafts that I will talk about. But yeah, this is kind of, let's see if we can have such kind of session in order to start to work on something. Okay. Who is here? Oh, all the attendees. At this point, I see 59 on the WebEx. You are welcome. I'm happy that you are here. We also invited specifically a group of panelists in order to share their experience and opinion on the topic. Okay, we believe that they have a say on addressing, which is the specific topic of today. So we have Dino Farinacci, Vasilios Giotas couldn't make it. He has some personal urgency matter to take care of. Dirk Kutcher is here, Robert Moskowitz, Michael Richardson, Nirmala Shinoy, Laurent Touton. Sorry if I misspelled your name. But anyway, the mic is actually open for everybody. So obviously the panelists have a small priority in order to share their point of view, and this is why we invited them. But the mic is really open for everybody. This is a discussion session, okay? So the agenda today is pretty simple. There is me talking for the first 15 minutes, and 5 are already gone. And then there is an open discussion with the panelists and all the attendees. Dirk Trossen will lead this part, okay? The topic, I mentioned it already a couple of times, internet addressing, because we published 2 documents, the one claiming there is a problem and one analyzing some gaps that we believe exist in addressing. So the reason is why sometimes we believe the internet addressing, the way it is done today, shows some shortcomings, okay? And in time, there have been extensions that have been developed in order to go beyond these shortcomings. But there are a number of issues that also rise where we have several extensions working at the same time, okay, or have to communicate to each other. So this could lead to some kind of fragility of the overall system, we believe. So, and this increases the complexity also. So we believe that it's time to think in a different way without urgency and see if there is something that can be done in the long term in order to evolve a little bit things. So we try to formalize our thoughts in a first draft, which is a problem statement. The draft provides basically few scenarios, actually several scenarios, where the internet addressing model shows some hindrance, some shortcomings. Let's say that it's not the best fit. This is in the context of IoT, or when we have mobility, which could be actually the changing topology or moving endpoints, communication across different services, traffic engineering, security, or even alternative forwarding architecture. So in this first document, we go a little bit over all of these scenarios, and we build a final question, which you can read at the bottom of this slide, which is, should limited domains, by limited domains, we talk about what is defined formally in an RFC, but it's the fact that limited domains is a domain where a specific solution has been deployed with a different way to do addressing, maybe. So if limited domains purely rely on IP addresses and therefore deal with the complexity of translating any semantic mismatch themselves, or should flexibility for supporting those limited domains be a key focus for an evolved internet addressing? So basically, should we keep it as it is and we deal with all the mismatch and we deal with complexity and fragility, or could we think beyond that, the current model, and see if we can do something better? Okay. And the second companion document is the gap analysis, which has a very simple structure in a certain way. We first discuss about 3 key properties of the internet addressing, namely the fixed size address length, okay, the ambiguous semantic, so this duality that we have in addresses about the locator mean semantic and the identifier semantic, which leads to issues in several scenarios, and the limited support for different semantics, which is today only prefix-based. Taking these properties, we go over a certain number of extensions that have been developed in time. And to us, this means if this extension exists, is trying to cope with a specific gap. So that's how we identify gaps that exist into a quantum model. Okay, and then we discuss a little bit the issues that we can have in the extensions that we overview in this document. Okay. Now, having said that, and I hope that you at least skimmed a little bit through the document so you have an idea of their content beyond what I'm saying here in just a couple of minutes. There are a few open questions that arise. So if these extensions show that there are gaps and you believe that indeed there is something that can be done and is worth thinking of this, a different approach, make it somehow the addressing evolve, okay? We are not suggesting here anything specific, but maybe start to discuss, and this is the right opportunity to start to discuss. And does the community agree that we can do something from an architectural point of view in order to make extensibility of addressing a key principle of future internet? Now, we can also discuss what extensibility exactly mean, but the main idea is that somehow the addressing model is more flexible to extensible of what we have today, and so maybe more helpful in solving or coping with the different scenarios that we have today and we will have in the future. Okay, so though basically the question to the community is that are you interested in this, and do you want to contribute by discussion or by text, or contribute to this in order to move this work forward somehow? Okay, and I'm done in 12 minutes. So I would hand over to Dirk in order to lead the discussion and start with the roundtable with the panelists. I will hold the screen in order that I'm sharing all the slides. Just tell me when to move forward.
Yes, thanks, Luigi. As Luigi mentioned, the role is mainly, from my side, mainly to be an animator, as you put it. The discussion is mainly down to the people we invited, but also to the wider audience. Just a bit about how we intend to do this. We've asked the various participants, panelists, if you will, to prepare some material. Some have either in slide form or verbally. That's totally up to them. We've gathered the material. Luigi will show the material when it comes to it. We've also come up with a certain order to go through, but that's not necessarily binding. See how the discussion flows. I've prepared a couple of teasing questions. That's the animation part. I don't have to ask them if the discussion goes, but in order to keep the discussion going, I may ask them to the various analysts based on the material we received, the communication we had, just to keep things going. I'd also invite the audience to either raise their hand if you have a question, put something in the chat. The team is also monitoring the chat in case there's an interesting discussion arising, through chat messages. We may formulate a question and throw it in as well. So we're trying to be as contributive as we can be. So bear with us. If you feel that your voice or your view isn't heard, just try to give us a better signal for it. With that, we're trying to do this in 45 minutes and then wrap up. Let's see how we move forward. So I'd like to start with Dino, who sent us a couple of slide materials. So I think Luigi has first, and maybe you can go through this first and see how we enter in the discussion. Dino, thank you.
You hear me okay?
Yes, very good.
Can you
Thanks.
hear me?
Yeah.
Oh, okay, good.
All good.
Okay, so I'm just gonna talk briefly about my experiences with dresses over the last couple decades. And after looking at applications, network layer, NATs, all kinds of middle boxes, what the least common denominator comes out of what I think addresses should be. Next slide. and the only slide. So for applications, and let's start there, I really think addresses should be opaque. I just think they should be X number of bits, and we don't even have to argue on how many bits they are, but it's something that an application has to use to keep data structure state, to distinguish one thing from another. Is it communicating to do two different endpoints? Is it talking about an object? Is it talking about a virtual machine and a lower networking context? It doesn't matter. It just needs something to look up in its own data structures to find differences for however its applications run. And I really think they should be endpoint identifiers and not have any association with any other parts on how an address is being used. So the thing about seeping the network layer address into applications causes a problem for mobility and for aggregation, and it also gives information to the application for the network layer that's usually not necessary. We have to have some structure in these addresses to optimize connecting endpoints together, and the structure doesn't have to be known by the application. It just has to be when an application asks for an address or says, give me my ID so I can tell other entities that I'm communicating with, you should be able to do that. Now, having worked with Lisp, we noticed for mobility that it's good to have a power of 2 structure in EIDs that are used at the applications. Again, the applications don't have to know about that. But the reason is that if you move a cluster of applications together, you want to be able to move a power of 2 block together rather than n distinct entities, because we save state wherever it's kept at the network layer or at some middle layer somewhere. So I believe there needs to be some structure for this endpoint ID. And because the address is opaque, the application should not know if this address is unicast, anycast, or multicast. The application decides if it's talking point to point to something for privacy reasons, or it's a master database or something, or it wants to find the closest thing. It really doesn't have to matter. It will decide what sort of identifier it should use to be able to talk uni, any, or multi. So for inside the network, we must have topological locators with structure. They must be a power of 2 structure, so we have aggregatability. That is critical. We've seen the internet work up till now, and this punching holes or doing prefix hijacking, these are all functions of power of 2 addressability. But if we can really make attachment points look like a power of 2 aggregates, then you never have to worry about punching a hole, because now an address, a locator, is not something that's moving. A locator is you're defining an attachment point to the network, and what's moving is the endpoint itself. The application is moving, the VM is moving, the container is moving, and those all use identifiers. We also want overlay mapping databases that map from endpoint IDs to locators to be aggregatable as well. And that's why I said we needed to have some power of 2 structure in the EIDs as well. I've seen on-prem set of applications, there be 3 applications rather than sending, or let's say 4 applications, rather than them moving from on-prem to a cloud provider. It would be good not to keep 4 pieces of state because they're all moving together. And so what's happening is this power of 2 block of EIDs are always associated with one locator because they stay together for a variety of application reasons. So what I think the future of addresses should look like is that we need them to be small for packet compressibility. We see this in 3GPP with 5G, even with the 5G network. We find that we need to optimize the RAN space, so we need packet headers to be small. And even if these addresses are not being used at the network layer, but used at the application layer, we want application level packets to be as small as possible as well. And you also want the addresses to be long because you want various levels of aggregatability, which we'll need in the future. So what I'm saying there is it's not a contradiction of terms. We need to have small and long addresses. And the only way to do that is with variable length addresses. And we could argue about, do you have to carry a 1 byte length to describe the length of the address, or do you null terminate it or whatever? And we could argue how many bytes an address has to be. But what I'm seeing more and more from like blockchain and Web3 distributed app applications is that what the applications are using now to either identify a wallet address or an NFT or a token, they're all public keys. And public keys are very handy when they're used to identify endpoints, because once you have to verify a signature that's going to be in most of the packets that this public ID is sending, you have the public ID right there to verify the signature. This is really handy. Now I'm talking about endpoint IDs here at the application layer, and not necessarily having locators use the same approach, even though some people will argue that it's good to sign individual packets or a train of packets and verify them, but that's another matter. But what's most important is what do IDs look like for applications? That's pretty much it. Questions?
Yes, thank you. Thank you, Dina. Is there any direct question? Otherwise, I have one handy. Does anybody have a question in the line?
I know, so this is Michael. I thought you're really right on almost all things. What I've observed is that applications are not they're being forced to do things with addresses that they shouldn't be. And as far as I can see, it's because we mapped IPv4 and DNS straight into v6, and we didn't stop to realize that actually the decision as to what address to reach for a given name and which source address to use to reach it has been left to the application, and our APIs are just wrong that way. And we really needed give me a 5-tuple even that will let me talk to this name. And people said we should put that in the kernel. And I say, well, yeah, probably don't want it in the kernel, but you certainly don't want it in my application. And it seems to me that there's that a lot of our pain points are directly related to the fact that the application winds up using the wrong address, and then the network tries to do all sorts of stupid tricks to preserve that connectivity. And when it was really the application's fault for doing the wrong thing, and they're excused. But how are we going to solve that is the question.
Well, I'm going to make a reference back to the old days for people that are old enough to know about the OSI network layer and stack. I remember we had these things called NSAP addresses, and they were network layer 3 addresses that were used in packets in the CLNS protocol. Those addresses were not exported up to the transport protocol. TP4, which is the TCP or quick equivalent, had these things called T selectors. And T selectors was an address used at that layer. And across the transport and network layer, there was an automatic translation that was done that this T selector mapped into this NSAP address. This was done locally, and it wasn't done globally. There was no directive. So it was just a local matter in the implementation of sourcing a packet or receiving a packet. The T selector worked really well, I thought, and it had nothing to do. It was something that when you opened up a TCP connection, like an ephemeral port, it was allocated at that point in time. Now it turns out that there was 7 strict layers at the OSI network stack, and most applications didn't know anything about T selectors because they were running at the application layer that had a session layer below them. And guess what? The session layer had an S selector, which was an abstraction from the T selector, and the same mapping was done going from the session layer to the transport layer. I think that was the right way to do things. And if you needed mobility at the session layer or at the transport layer, you have that because you decouple these points within the stack itself. So I don't know if that answered your question, but architecturally that was elegant.
That's a 30-year throwback, and
Right.
and there's other criticisms as to whether this was really a useful thing or whether it was just particularly at the time. of not very much RAM compared to today. But the question is, okay, so those are good ideas. How can we get back to that point? Is I think how can we reintroduce these concepts in an intelligent way, such that we can make some progress going forward?
Well, I mean, Luigi brought it up, is do we change the network that we run over and do it the right way, or do we transition over time and use the existing network? Is it a strong requirement to make the existing network work with a set of applications that run in this new world? I've been working on blockchain for a few years, and when those guys that are building distributed apps talk about the network, they're not talking about the network that we know about. They're talking about their peer-to-peer network that runs their blockchain protocol, and the bits that move back and forth on fiber and copper and routers and switches are something they just assume just works, just like electricity does when you plug it into the table, into the wall. But to answer your question, I think what we have to do is you have to use the underlying network, and you have to use it as is. But I think we can change the applications on top to have a level of abstraction. And that's what we tried to do with overlays, right? We told people that you're going to be assigned an IP address, but an IP address could be, what I do for a lot of applications, I assign the IPv4 240/4 address to applications and say, you don't need to know anything about that. And yes, we do tricks in the kernel to say that if you're going to send to a 240 address, make sure you source from a 240 address so it looks like, quote, an EID that's abstracted out of the network and that has no association of how you're attached to the network. But then you have to build a mapping database system that has to scale. And do you make that global, or do you make it local to domains, these limited domains, as Luigi said? I have lots of ideas on how to do this and been working on this a long time, but I think we could move the applications to a new world before changing the network layer. And we can build a new network layer and eventually make it have the overlay. The applications don't have to change to run over the new world. And we've shown this with IPv4 and IPv6, that if an application wanted to run IPv4, it could run over a underlay that's v6 or v4 or MPLS. We've shown this before, and it works. Like all these SD-WANs that are running, they're all running over arbitrary technologies and even running layer 2 over that stuff.
Thanks, Dino. Let me move on maybe to the second point. I think we took a couple of excellent notes, and we have some feedback in the chat as well.
One question to Dino, if I may ask.
Sure.
So yeah, this is an excellent point. Like Dino, you touched on 3GPP. So they put the architecture in release 15 and 16 for 3G for the various mobility scenarios with 5G. So the fundamental problem is like you have these IPv6 addresses. Every P gateway, so to speak, in the 5G world assigns the addresses to the endpoints, and when mobility happens, they come up with a completely different architecture to solve this problem, which complicates the complete network architecture, right? So it's not that 50 P gateways in one country, which backhaul all the traffic. The small segments of traffic happens, and the content, will be consumed at the local edge centers, and the network architecture is extremely complicated because you can't solve the mobility problem with that architecture. So your work on the EID's solution, I don't know what 3GPP responded. That fundamentally ties to the problem of addressing. Actually, here you didn't mention that, but it's a good point to indicate that.
So I think this is the same Uma I've talked to in the past. I've told you many times that the 3GPP network should just be another layer 2 network, and layer 3 should run on top of it, and all the mobility should be done at layer 3 and not down at a specific layer 2. Because then if you do mobility at layer 2, that means you only have mobility within that layer 2 network. And we know today there's tons of applications where people want to move from the cellular network to Wi-Fi. It's very popular. And to do that, you have to solve the mobility problem one layer above. So that's all I'm going to say about 3GPP.
I'm not sure but the mobility problem is solved by the layer 3. Normally, layer 7 at the application layer, you exchange cookies or things like this, and you can establish the link and move from one network to another. So you you construct, as you say, an identifier.
You could still establish cookies at the application layer because you think that the other end, you don't know the other end is moved because it has an ID that never changes.
Yeah,
The
so
fact that I've always told people that, at least in Lisp, EIDs are static. That's a feature, not a bug. We don't want them to change. Something has to stay the same because there's a dynamic binding that's happening underneath.
Let's move on to Dirk Kutscher, who's next in line.
Yeah. You hear me okay?
We can hear you, yeah.
Okay. Yeah, thanks for inviting me. Great to get this little OSI recap from Dino. Really enjoyed it. So I guess the reason I'm here is my work in ICN, where we are often concerned about naming data. And often there's a confusion between like, names and addressing. And so maybe we can discuss this later. That's not the point of the presentation today, though. Next slide, please. So please don't get offended by this, but if you have been hanging around the IETF for some time, I mean, you maybe remember all this discussion and debate with ATM, and we criticized it a lot regarding its utility for an internet layer system. The reason that, and of course there were many valid arguments against it, the reasons why we criticized ATM were not because you know, the VPI VCI structure didn't you know, allow us to express semantics or wasn't flexible enough and so on. The reason why it got criticized is that it was based on a virtual circuit concept, which clearly didn't really scale, had many complexities on the internet scale, and didn't allow for permissionless innovation and all these things. And so now the way I've perceived this addressing discussion so far is that, so we have people who basically take well, the internet and IP and say our addressing structures, and are not happy with it, and you know, find ways to think about, say, flexible structures, maybe expressing semantics and so on. And so I have some issues with this approach from the beginning, and so let me explain why. Next slide, please. So, I mean, I don't need to talk much about the design of the internet and so on, but just to remind us all, it was designed to do a few things really well. So scalable end-to-end communication, like the initial designs also emphasized resilience, adaptive networks, routing around problems, and so on. And so the address format was also designed to match the requirements, right? So we wanted to be able to forward the packets at line rate at the time, scalable routing. So Dino alluded to that. And then we also had additional technology to match this design. So like DNS, distributed database, even BGP. The point is that the internet that we all remember, and that was kind of the design at the time, doesn't really exist exactly like this anymore, right? So today, I mean, internet protocols are widely deployed, but we use them in a really different way. So this host-based end-to-end communication is really not the main use case anymore. It's really just users to the cloud and connecting eyeballs to content and hyperscaler services and so on, and content, and also, you know, functions that generate the content. And you can see that if you look into any ISP network, so how much of the traffic actually comes from traditional peering versus from the CDN caches inside the ISP network, and it's yeah, really a dramatic change. And still, of course, you could say so the problem statement draft talks about many, you know, use cases that I find a bit historic and if you want eclectic to some degree. And it's kind of not really addressing this new reality, I'm thinking. So the problems today that I'm seeing is that, first of all, I mean, if you are ISP, you have these operational complexities with managing all these different overlays. So one per service or CDN provider, someone is using DNS redirection, another one is using BGP prepending and so on. So that could be something to maybe consider for, changing the design or something of a system. The other point is that, well, the way that we do secure and privacy preserving communication today is really bizarre, right? So the whole web PKI basically was designed to support e-commerce, but it's really hard for any of us to establish a, say, secure, authenticated communication session without relying on any, say, centralized cloud resources as a rendezvous point or like PKI infrastructure. Yeah, everyone is aware of the surveillance problems. So these are real hard problems today. And also the recent events in like major CDN companies and so-called social network operators also show us that our systems are really brittle and actually don't have this robust decentralized design anymore. And you could say some root causes here, maybe it's just our success, right? Because everything has grown so fast, and so the internet technologies could be used and adopted for like new business ideas very, very flexibly, which unfortunately also has led to some, say, suboptimal design decisions, apparently. So the way that we use DNS, for example. And so you could say maybe also the way that our layer 3 today works. I mean, it's has this, say, well-defined purpose, but apparently it doesn't really support these new cases directly. So hence we have all these overlays. But my point here is that I don't think that new address formats will fix any of this. So addressing, in my mind, is just a consequence of architectural decisions. So like the ATM example. And so this is a much harder topic. And so if you start from a, say, router implementation point of view and addressing point of view, I don't think you will be able to solve any of these problems. So it's a bigger discussion in my mind. That's it. Thanks.
Thanks, Dirk. So if you, I like the second to last statement there, addressing the confluence of architectural decisions. One of the questions we are asking in the draft, if there is a wider architectural discussion required, I point. So let me reformulate that question. What do you believe are the architectural decisions that may lead to consequences for addressing? We have some discussion in the chat about the what versus where type of differentiation that also motivated ICN, which is an architectural discussion really. So what do you feel, is are the architectural discussions that we need, the architectural decisions we may need to take that in the end lead us to new forms of addressing really as an outcome?
Yeah, we probably need a bit more than 1 hour, but to discuss it. But I mean, one key aspect that I should mention is really security and trust. So I think that's something we have really learned, that, I mean, we have added it as an afterthought to our current layer 3. But what I think should really be possible, that like things in a local environment are able to establish secure communication relationships with each other without having to rely on like these big fortresses that we currently have. And so there are many other things that can be derived from that, but this is something where I would personally start.
Yeah, thank you. Any other questions from the panelists or the audience? We have a few aspects that from the chat we may want to tease into this. So I ask a question in the but again it goes probably back to the actual part that was mentioned before. You also mentioned on your slide that the host-based end-to-end is not the main use case anymore, but the addressing is focused on exactly that use case. So is overlay the answer to that always? Given that new use cases may not be host-based end-to-end, so we just continue to build overlays, or isn't ICN an area that has found a different answer to that?
This is Dino. I think overlays solve the problem, but it does come at a cost, and we have to decide and I believe the cost is this added entity called the mapping system. We could understand how to scale the mapping system just like we understand how to scale DNS, but can we really secure this thing in a global way? And does it need to be global is the question. So
I think that overlays are actually a really good thing, and I actually think the part of our problems is we don't use them enough. One of the things that I observe is that it's relatively difficult to get addresses that have real first class standing. ULAs are nice, but they don't come with reverse DNS. They don't come with whois. They're not easily debuggable in a lot of ways. And I think that one of the places where I think that we failed, and where I think that a lot of communities could use overlays more, is if they had the right to get actual addresses space to use that. That means either we do ULA central properly, or we fix some of our. I think we have created a bit of a IPv4 focused capital I internet only RAR and IANA process for addresses, and I really think that we need a different category of addresses which are not routable addresses, but are, from the application point of view, exactly identical. And from the service point of view, in other words, who owns them, how long can you own them, are they unique, are first-class citizens. And I mean, I've been through this with, it's never going to happen in the Aran region, is where I live. There, it looks like RIPE could possibly do something. The other possibilities is that IETF will instruct IANA to do something. But at this point, you know, it's hard to get that motion, that critical mass to happen. And I don't know what to do at this point. It's a chicken and egg problem, right? If there would be demand for them if they were available, and they would be available if there was demand for them. And I don't know how to leapfrog that part.
Michael, I think we shouldn't even ask that question. You shouldn't have to worry about getting addresses.
That's right. That's what I'm saying. Yeah.
Yeah. And you're allocated them dynamically, just like you are. I mean, we can learn a lot from the blockchain space. And the fact that I download a mobile wallet and I all of a sudden get an address, in other words, the key pair was generated, my wallet address was created, I can now talk to other things and do, you know, financial type stuff in this app. That's the way we have to think about connecting to the network as well. When you launch an application, your operating system will already have an EID that's assigned, and it might be a random number, it might be a hash of a public key, it doesn't matter. It's the thing that you're going to use as a source address. In fact, the application don't even know about it.
Who's managing that address space, and where are these applications getting it, and how big do I have to be to make that, to get to do this?
Yes.
Because I want to open a TCP connection to this address. I don't want to do some application thing. I'm an application writer. I don't want to invent all that. That's my operating system supposed to do that for me, right?
You as an application are gonna go ahead, Dirk.
So I think there's maybe some confusion regarding overlays. So Lisha also has a comment here in the chat. So of course, in principle, overlays are not necessarily wrong or problematic. I mean, the internet started as an overlay as well. But I think the problem comes from the way that you use it, and then in this current discussion, what you transfer to your, say, new addressing design. So for example, if we said now the network needs to be aware of application semantics, I would really question that. And so that clearly seems to be a say, wrong design decision. So any new system that, you know, might emerge, I think it's quite obvious that this will start as an overlay. There's no other way around it. And so Dino, I think you're also right in saying, well, if you want, say, end-to-end communication and routing for that, you need to have some notion of topological addressing. So we don't have any better routing technology today to like have a system where everybody can float around with their names and so on. So there would need to be some mapping at least. And my message here is that, so apparently there are all these really important use cases, and but so what's the right approach now? Is the right approach now that we should make our current IP more powerful and like forwarders more aware of what's going on in the application layer? So I think that's really the wrong direction. So instead, let's really think about it. So what is really, what are the problems? What are the really important use cases? And what can we learn from it for a future design, but not try to, do like minor optimizations with the addressing structures.
One note there. You're kind of like going exactly along the line of position the drafts. We're trying to outline problems. We're trying to outline gaps. We're not outlining particular aspects of solutions. So if this is felt to be moved to more architectural discussion, that's the question we're asking. How do we do this? How do you do this right? It seems from the discussion at the moment that there is a desire to discuss this, which is something we wanted to demonstrate with this meeting, right? And try to identify what are the questions we should even ask, right? And not what are the answers. Dino, sorry, in the interest of time, maybe I wanted to give the other guys a chance to.
We are strongly locked into the addressing we have. Applications, kernels strongly understand addressing. A problem you might say is that our world is addressing and things work with addressing. So if we're going to move forward and look at our gaps, we have to talk about what those addresses may mean in different contexts. We may be locked in that we have to work with IPv6 addresses, but how our world uses those IPv6 addresses underneath the application space is, I think, where we can identify where the gaps are, and then how we can architect some better designs, how we can architect variable length addresses in different places, how we can use compressed headers better, but we are stuck. We had a decision point 45 years ago. We didn't take it. We had a decision point 25 years ago. We didn't take it. We have what we have. And to rip it out and change it, there's too much invested in it in too many places. So our problem is we have addresses. What do we do with them? Let's identify the gaps around that and how we can make things work better dealing with addresses. And as Mike and Dino have indicated, there are potentially ways forward by separating the address space for different uses and allowing meta services that the applications don't see that make these things possible. We have a lot of experiments, a lot of things which have done this, and I made my attempt at it, and others have as well, and we know where we can go. It takes some new blood, and I think now, to do it.
There are some gaps, of course, in the story, aren't there?
Yeah, of course.
So, for example, there's a trend towards applications containing the whole of their network stack and just using the simplest possible, most basic output from the device. We're particularly seeing this in the sort of phone world. So that gives you one in, and the other in on the other side is that compute is moving right to the edge in order to achieve latency and other effects. And so if you cross out the word internet and make it networking addressing problems, then networks which may also be able to connect to the internet using classical internet modes may well find it useful to move to a different mode of operation where they use an address that is particularly enhanced for the types of service that they're trying to deliver. You don't have the mega scope problems you have as soon as you say internet at the beginning of the problem statement.
There's too much we have to rip out. We are here. What can we work with? What we have.
No, you're not entirely right. We're about to rebuild the entirety of the edge part of a very large part of the network, and they're looking for new services. So I would not give up all hope at the moment of building better communication structures that go between the terminal and the server, which will be very, very close to the terminal in many, many cases.
Maybe it's because
I want
I'm
terminal
at
to
the end,
terminal.
I'm ready to retire, ready to hang up my keyboard, and maybe that's why I'm looking at it this way, and need some new blood in here to run with it. And you
Well,
may well be right.
Well, I'm of the same age, and I'm not giving up yet.
Well, I'm focused, as I indicated, I'm focused on aviation. It's fun, it's interesting, it's someplace where I can make a difference, and that's where my focus is. But I still would like to see something done across the rest of it.
I think the next generation of people that are going to use the network are going to want decentralization. They're going to want privacy. They're not going to want middlemen. They're going to want two cell phones, two people in a cafe. They want their cell phones to talk directly to each other and not have to hairpin packets so other people are snooping on their stuff. That's the world we're going into. It's community based. It's decentralized. There's no big man. Proof of stake, those sorts of things are what that generation I see wants.
And it's not
I
just
disagree with you.
not just for privacy, it's for latency reasons.
Yeah,
right?
latency will be the driver. Latency and
matter.
bandwidth will be the driver.
I don't care the reason. I don't care the reason. It needs to be shortest path from source to destination, the least number of hops, the least number of boxes. That's my point.
Right, and the destination may well be in the street cab next to you.
Exactly, Stuart.
Right. So, I think we need to be a bit careful here. I think the fundamental driver that most users will have is, can I play my game fast enough? Can I shake the hand of this virtual person without throwing up because of the latency? Those will be the drivers, and they would take any solution. I mean, the person who owns the handset does not care what the communications protocol is.
Right. They want the lowest bid on a new shirt for their avatar.
Whatever.
And they want to pay it in Bitcoin. Yeah.
Well, I don't care how but all that's way above, and I don't care whether a whole load of that traffic has to go across the big eye internet.
It requires low latency, as you point out.
Yeah.
Okay, let's move maybe to Nirmala, who wanted to talk about the aspect of structured addressing in the discussion. Thanks for some of the links. Actually, I've seen Licia, the decentralization part is quite nice. You put in the chat. We're also going to make the chat and all obviously available, so you'll see the things later in case you can't follow some of the discussion on the chat. And Robert, good to have you back. Sorry for WebEx kicking you out.
It was the computer I was using. I shouldn't have used that computer.
Oh, lesson learned. Nirmala, please.
Okay, can we go to the first slide? Okay, I think we're going to skip this one because this was already covered by Luigi. Okay, we can skip this also. Okay, so some of the major challenges to our investigations that I would like to discuss, as I've been participating in this IETF work for some time now. So what I have put up here in this slide is some of these challenges that we have listed there, and some are from my own perspective. So one challenge is, how do we interwork with the variability in limited domains? I'm currently alluding to the two drafts that were put up there. And these limited domains, there are several that have been listed in these drafts that are currently coming up. And there could be several more coming up in the future as well. So the question is, I mean, this has been a discussion till now. Do we modify, extend, replace IP? And actually, I had changed the slides a little bit. Looks like there is a time delay between the time I send and Dirk receives my slides. Sorry about that, Dirk. Okay, so the question is, do we modify, extend, replace IP? Several of these initiatives have been tested out. And one of the initiatives that I'm working on is where we are trying to displace IP, that is trying to move it out slowly. And in the interim, we can still work with it. You have both IP and our solution working together. So I consider that to be one of a viable option to this major challenge of how do we handle this widely deployed internet protocol that is there, that's out there. The other thing that we do mention in our drafts is that we are going to be working on addressing only, and that too from a data plane perspective. And my own opinion on this is if we work on addressing only, this can surely impact the control plane operations. We already noticed that routing is pretty complex out there, and we are stressing BGP to limits. At least that is my observation. And if we try to look at addressing only without trying to look at its implication on the control plane operations, we might be facing some more challenges in the future. Next slide, please. So where do we go from here? So we have to start with some assumptions. So I have listed some assumptions here, and the limited domains that we are considering in these drafts, they are going to continue. We are not just, I mean, whatever is listed there is just not all the limited domains that we are going to have. They are going to continue to evolve. They're going to continue to grow. So what are we going to do with the addressing scheme that we come up today, and then try to retrofit it to these to the requirements of the limited domains? And that is not going to be very efficient. Any retrofitting, we all know, is not going to be very efficient. And one more thing we also have to consider is any addressing scheme that we are going to come up with, and I'm looking at it from our solution perspective, we have to accommodate for IP. IP is there to stay for some time. So any extensions, modifications, whatever we propose, we have to consider IP to be there at least for some time. And security, the way I would go about it is, okay, you have these limited domains, and looking at the different limited domains, they have their own security requirements. So I would suggest that we should leave these security requirements be domain specific, leave it to the end systems, and not sort of try to wrap it up into the solutions that we are trying to provide in terms of addressing the problems with the internet addressing or whatever it is. Internet security, I mean, let us not go there at this point in time. So next slide. What's a good place to start with? I think a robust mechanism that can embrace not only the limited domains of today, tomorrow, and IP. By the way, IP is a very robust mechanism. It is a simple mechanism, but based on all the discussions we have had so far, we all know that it was developed easily several decades ago, and it was pretty suited to that networking environment at the time it was developed. It's a great protocol, but it did not address all the evolving networking requirements that we have today, all these limited domains that are coming up, and we don't know what the future is going to hold. So the goal of any solution that I would look at is deliver from the packets from one endpoint to another, and this would have least impact on the domains. And anybody interested in that can actually look up our work in this area. It was called the Expedited Bypass Internet Domain Protocol. Expedited Internet Bypass Protocol. And that is exactly what we are trying to do. And because of the capabilities of this particular protocol that we have been working on, we do not touch the domains at all, and we do not touch the internet protocol. We sort of work in parallel with the internet protocol. And what we try to do is we pick up the packets from one domain and deliver it to any other domain based on whatever addressing scheme the domains would like to use. So what is different about this? And I wouldn't say it is different. I saw it in Dino's presentation also, that using structures and locations as addresses could be good. And that is exactly what we did in our protocol. We used structure and location-based addresses, and we use these addresses. It is kind of a, it's not an overlay. It is encapsulating IP packets. So it is very similar to MPLS, but unlike MPLS, we do not depend on any routing protocols. It does its own routable address assignment, and then it routes the packet, and it encapsulates these packets, whether they come from limited domains or from IP and networks. It encapsulates and delivers it from one end to the other end. more importantly, that was the goal of our project, was actually to simplify routing. And I think I'll stop with that.
Thank you, Nirmala. So looking at, I mean, also knowing a bit about the EIBP work that you mentioned, have you identified any other use cases beyond embedding the structure of the interdomain routing system into the addresses that you looked at? You mentioned in the exchange that we were having that you could somehow, address security or routing security aspects through structured addresses. Can you say a bit more about that? What you had in mind there?
Okay. Like I said, again, when we started working on this protocol, the goal was, I mean, part of it was security, but predominantly it was trying to address the routing issues. And but there are some nice features. Currently, the IP addresses, you sort of address them on, whoever wants it, give it to them. So they have been allocated in an ad hoc manner. So that has really complicated the routing situation. So when we looked at our addressing, we tried to use structures and locations. And one of the things from a security perspective that I have looked into is, like I said, if you're going to forward packets between limited domains, then let the limited domains use their own security, and they can encrypt the packet and send it, and we do deliver it to the other end. They can decrypt it and use it. So it can be domain-specific security. So the scheme allows for domain-specific security. One more feature that we investigated is the fact that when we are allocating the routable addresses to the routers, okay, so it's not just allocating addresses on a demand basis or something. The addresses get tied to the ports of a router. And it's very difficult for a rogue router to come in and sort of introduce a whole lot of spurious routes and get into route hijacking and things like that. So that is the only thing we have investigated from a security perspective.
Okay, thank you very much. In the interest of time, I just wanted to give Laurent a chance to. We haven't touched an area that's covered in the draft, and it's maybe one thinks about problems of addresses in particular, and that's the IoT part. So yeah. Laurent, if you.
Yes, thank you. Do you hear me? Yes.
Yeah.
So yes, I'm working in the LP1 working group. And we are facing a very constrained network. It means that, for example, in some network, you have only 10 bytes of payload or 100 bytes of payload, and we want to put IP because we need interoperability. It means that we can establish a direct link between, for example, a device and a cloud application, but it means that the device has to be designed for certain services, or the service has to work for a specific device. So IP is interoperability. It means that you have some boundary between your device and the applications. So that's why it's very important to keep this. But of course, we cannot put it in IPv6, for example, because IPv6 is too big for the network. And also, you don't have a very good performances because you send a lot of headers for very, very few information. So what we have deployed, it's designed, it's a compression mechanism that is called SHIC, and allow to reduce the IP on over headers to a few bytes. And this way, we can carry IP packets on very constrained devices. So it's what we have done right now, and what we present it as a compression mechanism, and it has very good property to be like IP. It's a datagram compression. It means that you don't create a flow, but you compress packet per packet. And so what we can imagine also is that if we use the same compression rule for a group of devices, it means that we can have another packet format that is dedicated for certain applications. And then when we want interoperability, we can reconstruct the IPv6 on all the upper layers to talk with any kind of application. And I think that it's something that is very important in the internet is this interoperability feature. It means that if we develop a specific network for a certain application, it means that it will be very, very difficult to make the network evolve. So the IP layer has to be as flexible and can carry any kind of application.
Thank you, Laurent. So any question on the IOP part? Laurent, the question from my side on the addressing flexibility that we're outlining in the draft, would you see in any way this applying to SCHC, and then do you see that addressing flexibility would change anything in the approach how IoT devices could be more efficiently connected?
Yes, I think so, because for example, when you are in a star topology, you don't need to send the address because you have a point-to-point connection, and so you know in both ends who is talking to. So this way you can have a very, very high compression. But if you are in a mesh network, maybe you just need to send the last byte that can be used for the routing. So it's something that has to be adapted. And the advantage of SCHC is that it's very flexible. You design your rule for a specific kind of application. And if you want to change, then you change the rules.
I may have a question on this specific topic, because to me, to be honest, IoT is a clear example of the fact that we have different domains that use different addresses or addressing model. Is because in IoT, as you said, Laurent, you have very small packets, so you try to limit everything. So at the end of the day, what we develop in IoT, from my perspective, is a different network layer. And then we do translation in a certain way at the gateways with the help of solution like SCHC. So my question, I guess, is, can we have something more flexible that allows to have a simpler approach on the gateways, or reduce the complexity in a certain way? And this is also about reachability, because those nodes are not in the DNS in a certain way, or unless only present in the IPv6 counterpart. So make them to appear it's complex.
You may have your host in the DNS. And when you reach a gateway, then you don't need the address. You can compress the address. We can even ping the device and the gateway is answering. So it means that your host looks like an IP node, and you have an identity that is IP, and so you cannot make the difference between Wi-Fi nodes or Sigfox or LoRaWAN nodes. So you manage all your devices the same way. Of course, you don't have the same bandwidth, but in the architecture, it's exactly the same, and it simplifies a lot of things.
Yeah, but this does not solve the translation issue in a certain way between addresses, because you have such a complexity in the gateway, and I wonder if
we have complexity, but we have also very limited traffic. It means that we can spend more time to forward a packet than in a core network on the core router. So here we are at the boundary, and if you look at the throughput of a LoRa network, it's quite limited compared to what you have in Internet Core.
Okay.
Thank you. We're approaching, unfortunately, already 10 minutes late in our agenda. A number of aspects that I cross-cutting questions, which I've actually covered quite a bit in the chat. I try to follow things. We didn't talk much about privacy and security. Security a little bit, privacy less. There's been quite a bit of discussion going on in the chat about it, which is good. So we can try to tease certain points out there. I think a question maybe where we can close the panel a little bit, for today. our discussion for today is we outline the way the gap analysis is structured, as Luigi said before, is outlining the various point solutions that do exist. And one of the questions I had was whether we believe that the various point solutions to addressing and the extending addressing in the way we know it will fail. When is the fragility really kicking in? Do we have good examples? We are lacking this at the moment in the draft, where the coexistence of point solutions leads to a number of issues. What are those issues? What are those problems? Does anybody have an example maybe available or be able to contribute to that question?
There is maybe Colin raising the hand. Maybe he has.
Oh, okay. I didn't. Yeah.
Kind of wanted to follow on a little bit from that previous discussion, but also to sort of address some of the broader points, perhaps.
Mm-hmm.
I mean, following on from the previous comment, I would argue that bits are cheap. I've been participating in IETF for more years than I would care to think about, and over those years, I've seen the community build many different mechanisms to reduce overheads of various protocols at the cost of tremendous complexity. And most of those mechanisms are now completely obsolete. And they went away as the network got better. So I would argue that we don't need to completely redesign the network to address today's temporary issues, right? It's okay to have local workarounds, even if they're perhaps a little bit kludgy, that they'll go away. I think more broadly, I thought that Dirk Kutcher and Stuart Bryant made some very interesting points. And I tend to think that addressing is not the interesting problem here. We're not going to build and deploy a new addressing model for the internet. We're just not. It's far too late. We're struggling, I think, to deploy IPv6, which was actually a pretty small change to the addressing model. What I see happening is rather that we're getting a network that's becoming more programmable. We're getting the equipment that gives us the flexibility to deploy different addressing, different route schemes, different forwarding schemes, put in more complex, more flexible packet processing, in network caching, all of these things, and do that in different parts of the network to perhaps support different use cases. So I tend to think that the interesting question is not how we change addressing, but rather how we incorporate programmability, how we incorporate programmable addressing and forwarding and so on, where different parts of the network use different approaches. I don't think addressing is particularly interesting, right? What's interesting is internetworking in a much more programmable network. Do I think CDNs are a feature or a bug? Yes, I do.
Okay, Colin, thanks. I think Luigi answered the question about, or the comment about replacing the addressing model. I don't think they're claiming that, but the point is well taken. Right, the discussion is about how do we evolve addressing and the use of addressing, including in programmable environments. Whether that leads to a new addressing model or not is a question that we haven't even asked, right? Let alone answered. So I think that's important to understand as well. What is the stage of the discussion we're currently at?
Yeah, I just think that the focus on addresses is not the interesting part.
I'm wondering whether addressing is actually reducing our ability to see the bigger picture, because we talk about addressing, whereas what we're actually talking about are interactions and communications. And
yes,
I think maybe, you know, we're sort of got too short a focus when we say addresses, because addresses mean actually a lot more than just addresses. You know, they mean instructions. They're an implicit instruction to deliver something. People are adding other instructions. MPLS overlaid the whole concept of what other people thought were addressing with function calls. So maybe by using the word addressing, we're actually limiting our scope of thought to a smaller domain than it should be.
And that can be then mapped to addresses for making it deployable. But first, what do we want to map before we go to IANA, ICANN, whoever, to say, we need some addresses for this? What do we want it for? Do a good point.
If I may add just a quick observation, I agree a little bit with all in the sense that is addressing the key point that we should evolve, not replace, not make a revolution. Let's be clear, and we are not suggesting anything. We want to start a discussion, but yes, network programmability can help. Absolutely. Is there a bigger picture? Certainly, addressing is not something isolated. It's part of the architecture, the IP architecture. And as such, if we evolve one aspect of this architecture, we are evolving the architecture. And we cannot do it in an isolated way, absolutely not. So it's a way to tackle the problem, in my opinion, is a way forward that can be helpful and accommodate future, present and future use cases. Yeah, but it's a fair point that what you all said in the last couple of minutes.
So yeah, let me summarize.
Another aspect to bring up is that see, the programmability, I think I completely agree with Colin, but to the extent that I think it's a prerequisite to do anything new, right? Because it just gives us agility and flexibility. And the fact what Stuart said, that we're talking really about instructions instead of addresses, I think is fundamental. I think the reason why, you know, I like to call it addressing is from the experience that we had with multicast, right? Which is basically we didn't have to reinvent a whole new network layer to bring it in. We could simply carve out a part of the address space in the IP protocol and get a lot of simplification of not having to, you know, reinvent the whole layer 3. And, you know, in Beer, for example, we couldn't do this because we didn't have long enough addresses. So we did have to reinvent a whole new network layer with all the associated operational pain that comes with it. So that, I think, is one of the main points of looking into a more flexible network packet header so that multiple different individually programmed, you know, semantics can be brought together easier in a future network.
We should have spent more text on Beer.
Well, I'm going to have one after.
So I just, there's a comment in the chat about addresses should be backwards compatible, etc. Depends where you mean it backwards compatible. They don't need to be backwards compatible in the data plane, so long as there's a common reference point from which you can translate from one to another.
Thanks, Stuart. So with that, we are 20 minutes over the time, and in the interest of everybody having some sort of finish for today, it's been a long day. I went through an exercise of a very, very different scope, very different community, but we agreed in coined the terms that what we're actually after is agreeing on the disagreements, and hence I do see the various points being made, but I think the agreeing what the disagreements and what the main pertinent points of discussions are, that's really what we're after with that. And maybe at the end of the day, we do figure out that addressing in itself is a limiting scope of looking at the real interesting things, but that in itself is a good discussion, may lead us somewhere. I think one of the other objectives that we had with this meeting is to see what discussion we can actually really create with this work in the area. As Luigi pointed out, there are certain problems, possibly through the current pure online nature of the meetings, that discussion just didn't happen in the way we felt it could happen, not just with our work, but with other works. I think others are struggling with it as well. I think the meeting, at least today, has shown there is quite a bit to discuss around addressing, whether it is addressing or not, whether what addressing could be, and what are the aspects of addressing we should be talking about. And we would like to carry this discussion over to the mailing list to see what is the type of discussion we should be having, because that's what we're trying to figure out with these two drafts. Again, if you read them, you will hopefully notice, unless if you think otherwise, do tell us that we're not putting out a solution. We're trying to frame a discussion. We want to see what the discussion should be. And this today at least has helped us. It has as being, yes, that's correct, Olaf. The mailing list is the in-area mailing list indeed. Sorry for not being clear. So please carry on with the discussion there. It would be really helpful. If there are contributors to the drafts to make things clearer, please help us with that. We are always happy to have your thoughts being weaved in. We either do this straight from the material that we could gather today, or we will do this by maybe also approaching you, at least asking you if you would be willing to help us, so that we can scope these things down to the interesting points that we can find enough common ground for discussion. I hope that explains and also ends what we wanted to achieve with that. At least from our side, I think we can state that we did that. I hope it was a useful meeting for you guys. I thank the panelists for their participation, the various people in the chat for their contributions, and for everybody who asked questions. Thanks for staying on, and you guys have a good evening, morning, afternoon.
Thank you for the panelists. Thank you to all for the discussion.
Thanks.
Very interesting.
Thanks. See you soon.
Thanks, Doug. Bye.